Hello and welcome to the latest edition of Meraki Unboxed. My name's Simon Thompson. You can find me online at Meraki Simon. I'm super happy to be back with you again, and I'm joined today by one of our esteemed Cisco consulting systems engineers, Jeffrey Handel. Jeffrey, how are you doing today?
I am doing great.
All right, we're going to talk about IPv6 on today's episode. But before we get into that, I just want to quickly remind you about Meraki Unboxed. We do this every couple of weeks or so. And what we're trying to do here is bring you content which is, really partly about our technology, but also about what life is like at Meraki as well. So today we're definitely leaning into the technology a little bit with this very exciting topic, IPv6. And what we wanted to do was just explore that and how we're using it at Meraki, how we think about it. And Jeffrey, I've known him for a number of years now. How many years? I don't know how many years.
About 4 years now.
Is that 4 years? Oh, time flies. So I've known Jeffrey quite a while, and every single time he visits our site, he's actually based out in the field, going out and seeing customers every day. But when he comes to our site, he makes a beeline for my desk and says to me, hey, what are we doing? What's the latest on IPv6? You need to write about it more. You need to tell the world about it more. He's like the biggest advocate I've ever met for this technology. So does that sound approximately right to you?
Yes, sir. And actually, I would call myself a self-proclaimed IPv6 evangelist.
Whoa. That is a great job title. I love it. All right, so tell us a little bit about yourself and your background, and how long you've been in this industry, and what brought you into Meraki, and what you've been doing here.
So I actually came from a little country in Central America called Honduras. I had no exposure to computers. One day, my parents decided, hey, maybe you should apply to university in the U.S., and I ended up in Louisiana State University, not knowing what Mardi Gras was, or Cajun people, or Cajun food.
Surprise!
So it was a interesting awakening, and that same awakening, I was exposed to my very first email and computer. If you actually look at how the way I type, you can tell my typing skills are not the greatest. But it did open the world for me to this whole world of networking and what it is and how we communicate and all the possibilities.
All right. And so tell us about how you got into Meraki then. How did you find out about the company?
Well, it was by sheer accident, too. So while being at LSU, I became the network architect. So I went from not knowing what the hell the internet was to running the entire show for the state of Louisiana.
Wait, so you were a student there?
I was a student, and I ended up becoming the network architect from being a student worker, although got hired on.
Wow, hands-on.
And that's where I kind of learned about IPv6, because I said, oh, what is this thing? It's been around for 10 years. Nobody's done anything with it. And
true.
This was around 2005.
Okay. All right.
And that's when I said, hey, maybe we can do some research, get some grants, make some money. And that's essentially what we ended up doing. Didn't ask for permission, just went out and did it. It was very, very painful back then. Almost anything didn't work, but it did get a lot of people's attention, especially Cisco. We became a kind of an alpha and beta test site, even though they wouldn't tell us sometimes we were alpha site, but we were testing a lot of the V6 components they were putting into all their products at scale. And come 2014, 2015, that's when I discovered Meraki, and I'm like, oh, this looks like very interesting. However, I can't buy it. It doesn't do IPv6.
Right. So let's track back on that at some point. And I remember this technology. I have a few years on you. I've got more gray hairs than you have, Jeffrey. We can't see this on the podcast, but I'm prepared to share it with the audience. Like 20 years in this industry. I think this year actually 20 years. In networking, and so I've been hearing about IPv6 for almost that long. And I think one of the things that we're definitely going to unpack today is, first of all, like how it's different from the regular IP addressing, IPv4, that we've been using on the internet basically forever, since day one. And also why it's been hanging around for so long, and why the adoption's been a long time coming. So let's look at that, because you can think of me, and Jeffrey, you know this very well. You can think of me as a little bit of an IPv6 skeptic. Like I think that we have figured out some good technology workarounds. So what I want to do is explore. First of all, let's start. Let's keep it simple. Let's start at the basics. Maybe explain IP addressing and IPv4. This is a great challenge for you. To the audience, like not too technical, not too deep. How would you describe IP addressing?
Oh, do it in English is interesting. So IPv4 is essentially using 4 little numbers that range from 0 to 255. We typically call them octets to represent a value that is assigned to your device. So it's one for one. It's the way that you can communicate on the network, and it has to be unique.
Yep. And part of that IP address is made up by representing the network, and part of it's made up by the clients themselves, right?
Correct.
Yeah. So, but there are some limitations.
Correct. Because we've hit a finite limit. So getting into a little bit of math, there's this thing called binary math, which if you remember your powers, if you raise a base 2 to the power of 32, that gives you about 4 billion things. And that's the hard limit that we are subject to around the world, which is why IPv4 is finite.
And that's actually an important point that we should clarify. I'm sure many of the listeners know this, but perhaps some who are listening don't, and we want to make sure we don't leave anyone behind. I think the key point that's of note here is that the IP address that your computer often gets is a private address. So it often starts with something like 192.168, or it might start with 10, or it might start with 172.16. I'm testing my own memory here, but I think those are right.
Those are correct.
And there's a couple of others as well. And those are private addresses which they can be reused and are reused many millions of times around the world on private networks, both in workplaces and at home. But the addresses that we're really talking about and we're really interested in here are the public IP addresses, which are used to communicate across the internet. And those are the ones where this cap limit is hitting us, right?
They're finite for sure. And actually, when they were created thinking that would be enough for the world, but this was in the 1970s. So they didn't realize what they were sitting on.
Now, you've reminded me of a quote which I should have prepared before we came along, but it's a really good one about how somebody, maybe it was Moore and Moore's law, perhaps it's related to that conversation, but it was somebody who said that we don't think they'll ever need any more computing power than this, and it was some very, very super basic calculator type thing. So we've moved on way past that, and now we're into a world of massive proliferation of devices, the ones that we have in our pockets, the ones that play our music, the ones that answer our call for help at home, and also these sensors we're starting to see. So I guess that's the problem, right?
Yeah, that's the problem. And it kind of reminds me of, and I'm going to date myself a little bit, Back to the Future, when Marty McFly is on the hovercraft there in the future. I mean, everything he's wearing can communicate with him, talk to him, tell him, hey, you're drying up. I mean, that's the future that we're starting to create. I mean, Nike's already need an address to be able to communicate with your phone, tell you how many steps. I mean, it's becoming that reality 20 years late, but it's becoming a reality. So we need to be able to have a way to allow everything to communicate with everything if we wanted to be able to do it.
I can't believe that we are describing Back to the Future as a prescient movie that actually foretold this reality we're in 2019. That's I don't know what to say about that. So, okay. So let's maybe think about, and here's where I'm going to bring in a little bit of a challenge to you, right? We talk about all these little devices. This smartphone in my pocket right now has a private IP address. It has a 192.168 probably, and that's probably the same case for my smartwatch I have on my wrist and my computer that I'm recording this podcast on. So if that's the case, and we're translating that to a public address at some point, but if I've got all of these private addresses, why is this such a big concern?
Because if we go back to the original intent of the internet was to create point-to-point connections. So just look, me and you having a conversation right now in this room. I'm looking at you. I'm sending you directly my voice, which think of a packet of information directly to you. I don't want to point my way to the right, have somebody else send it to you, because we know what happens in school, right? You the message kind of gets lost, translated, or it becomes a different word.
Right.
So if we start recycling all these addresses and converting them to public addresses, think of that, the message getting lost along the way. We're slowing it down. We're creating this lag. There's so many things that could go wrong.
It doesn't feel clean and efficient to you.
Correct.
Okay. So, all right, let's just make sure that we're very clear on the differences between V4 and V6. We've talked about V4, so maybe if you could just describe for us what IPv6 looks like, what an address look like, what's the kind of scaling that we're talking about. Maybe cover those.
So IPv6 is, even the word is hard to say. It gives us orders of magnitudes that are insane. Just to put it in context, just imagine every single grain of sand that exists in the world is an address. That's an enormous amount of addresses that could be available. So that's the kind of scale that IPv6 allows us to have.
Can you even remember the number? It's like
it's a
I would expect an IPv6 evangelist to know this.
It starts with something like undecillion something something something. Right. And since English is not my first language, that's one of those words that's probably made up.
That's a great get out. That's a great get out. Nice work, Jeff. I like the way you sidetracked that one. So what you're saying basically is we're never going to run out of these. We have really, really gone crazy here, and V6 just it looks different, right? I've seen a V6 address. It looks completely different. How many octets are we talking about?
So the reason it's still binary, still ones and zeros, but to represent it to us humans to be able to look at it and be able to consume it is we've used hex. Hex typically uses from 0 to 9 and A through F to represent these binary bits. And that way we can consume it, which allows very interesting things, which we couldn't do in IPv4, which is one of the reasons I really like it is I can now get really creative and actually embed words into my addressing scheme. So, and we've seen public companies such as Facebook do it. If you ever look at their DNS address for V6, it actually spells the word Facebook with a C instead of a K, but there's no K in what I just described.
Nice.
We work for Cisco. I actually, in my home, every address I have spells out the word Cisco. So C15C0. And that way I know it's definitely me that's running this network, and I know how to troubleshoot. This
is how we know the nerds are in control at this point, right?
Yes, sir.
Okay, so what you're saying then is if the world adopts IPv6, we've got a cleaner, more efficient. We can just do away. From your perspective, you see network address translation, NAT, as an anachronism. It's just a technology we don't need anymore. It was
originally invented as a Band-Aid, but that Band-Aid, we haven't pulled it out yet. And the creator of it was very clear that that's what the intent was.
Right. I think it's actually you've reminded me of another technology which is still around, even though its inventor expected it to be long gone by now, and that's spanning tree. I think Perlman was it? I think it's Perlman who invented spanning tree, and she thought that this would be long gone technology by now and replaced by something more efficient. So I get the logic, right? We should be trying to do some things a little bit better than we've done them in the past. We don't have to keep on going on and on and on. And I think the reason V4 is still, even in 2019, is still vastly prevalent is that we've managed with network address translation to keep it going for a super long time. I'm not going to defend it anymore. I'm going to accept your logic about this is cleaner and better technology, and therefore we should move to it. So it makes sense on that level. So maybe tell us a little bit about how the adoption of V6 has actually happened in the real world on the internet. Who is using this thing right now? What parts of the internet are using V6? We'll come back to Meraki later.
Yes, sir. So so people still think that IPv6 is still not a thing, even though they're using it on a daily basis. And the reason I say that is because who's adopted it has been the mobile carrier. So almost everybody around the world carries a cell phone in their pocket. They don't realize that sometimes those networks are V6 only, and it just works. And that's the beauty of it. It should just work. It should be, regardless of whether you're running V4, V6, people don't even know that that's going on. So that's one. ISPs are the other ones. Typically, since we're here in the U.S., typically if you get a Comcast, AT&T, Spectrum, they are delivering IPv6 and IPv4 to your network. Now, in some parts of the country, they're only delivering IPv6 because they are running out. So that becomes a problem. And again, users should not know. They don't notice a difference. It just works. Where we've struggled as an industry, it's been in the enterprise space because the ones that are in charge, us, are kind of scared of change, of trying something new. So that's where we could probably make a big dent in the industry, is where the adoption has been weak. And then the other part of the equation too is the content providers, the Googles, YouTube, Facebook. Almost every single piece of social media has been using IPv6 for quite some time, since probably around 2012.
So they're thinking forwards, and they just don't want to be messing around with unnecessary, out-of-date technology for no reason. But they're delivering. You mentioned the Comcasts of this world, the service providers. They're delivering both. They're using both simultaneously. How does that work, and why are they doing it?
So we typically call that dual stack. And there are both technologies, IPv4 and IPv6. Both stacks are independent of each other. So some will say they're completely orthogonal. So they don't know about each other, which makes it seamless. Now, there's some situations where you still need an IPv4 address because your content, your favorite article or Reddit or wherever you like to go is still v4 only. But if you're on a v6 only network, what do you do?
Right.
And that's for that purpose we still have transition mechanisms to help us bridge that gap, because we're in that transition going from a v4 to a dual stack network, and dual stack, by the way, is a transition mechanism. To v6 is the is kind of the what we're trying to aim to.
Right.
To
okay.
get.
So we're basically going through a period of temporary inefficiency in order to get to the promised land on the other side.
Correct.
Essentially. So are we saying with dual stack then that we're sending like one payload but with two headers with two destination addresses? How does dual stack work? And let's try and keep it as plain English as we can.
Oh, this is a great topic, because I'm going to use a very technical term to describe how we solve that problem when you have both types of header, both types of addresses. It's called happy eyeballs.
What?
That's actually a technical term. There's actually an RFC that the IETF put out called happy eyeballs, which is essentially kind of putting the human in the driver's seat. When we open a web page like google.com and you have both addresses, it's going to try to hit google.com and resolve for it with both v4 and v6. However, here's the catch. v6 has a head start of about 300 milliseconds, which was the original spec. And then v4 tries. And then it'll start using whichever one responds first. And which means for you as a user, you just want it to pop open and be ready to go. It doesn't matter if it got delivered via v4, v6, hence the word happy eyeballs, because you just see it get delivered
what
quickly.
You wanted.
Yes.
And I think if I understood what you just said correctly, it's going to be very small and maybe imperceptible, but there's going to be a slight speed improvement by using IPv6. Is that correct? I've never heard that before.
That is correct. And that not only comes from happy eyeballs, the industry has adopted and given the preference to v6, but the routing tables around the world are a lot cleaner and more efficient, because we've learned a lot of the mistakes that we've done with v4. Also, there is no NAT. Every time you have to manipulate a packet and convert it from one form to the other,
right,
even though it's v4 to v4, from private to public, you are slowing it down.
It's got to take some time to do, right? It's quick, but it's not. It's still going to add up if you're doing it multiple times from point A to point B.
That is correct. And it's 2019. We've grown very, very impatient. We just want things to work now.
That is so true. Yep.
And if we could add 20, 30 milliseconds to a transaction, you're going to make a lot of people very, very happy.
Right. And that's a great point. And we're constantly looking and getting excited about faster new technology. This year we've been talking about Wi-Fi 6 and 5G in the cellular world. And even before people have thought what they're going to do with this extra performance, the pursuit of better performance is relentless. And you're actually telling me something I didn't know before we sat down, which is that in some ways IPv6 is kind of contributing to that effort to keep performance always advancing.
Correct. And there's a lot of studies that have been done that go to prove that point. And that's why the content providers went and adopted v6, because they want you to have a good experience. Come back. That's why Facebook, Instagram, Google went to v6, because if your cell carrier is on v6, you want to have the best performance to their content,
right,
so you can keep coming back.
That makes perfect sense. Okay, then. So, all right, you mentioned that enterprises are aware it's a little bit more of a struggle, but it's clear to me that this is a technology we should be moving towards and making every effort that we can to get there. We also, I think, have discussed the inertia that exists, because people are quite happily using what's always worked for them and they don't want to break it. But if we want to make the internet a better place, make it work faster, v6 is part of that package. How do we evangelize this further? Obviously, I think within tech circles, IPv6 is pretty well understood at this point. But what opportunities and how does it get discussed to try and sort of advance its cause?
So you said something that really caught my attention, that it is pretty well established in tech circles. It actually is not, and that's part of the problem.
Okay.
It's still, when I discuss IPv6 through internet too, even within Cisco, because we have a group called the IPv6 ambassadors, it's still the same people that have been around for the last 10, 15 years. It hasn't changed.
Right.
Instead of growing, it stayed the same, or people have been retiring. And so that is part of the problem.
Okay.
Is the fear of change, and people are not actually seeing it, how it can solve problems.
But it is kind of crazy that if it's being used so widely out there on the internet, and I think I'm trying to remember the date when the world ran out of net new v4 addresses, so that you can only now recycle. That a couple of years ago, right?
That depends on the internet registries. For North America, and more specifically, that was the one that had the most, and that was the one that became the most impactful. That was around 2013, 2014.
Wow.
And I kind of helped in that regard, because the last few subnets that were available, I kind of went and requested a /16 because I didn't believe in that. And so I kind of helped exacerbate that date a little bit when I was still in the industry.
Whoa, this is an interesting fessing up that we're getting here on the Meraki Unboxed podcast. It's fun stuff. All right, let's bring it back to Meraki then. So we are a player here. We generate equipment that people use to connect to each other. We have all of these. We support all of the regular protocols, in spite of it being like a super easy, intuitive interface that we've become very, very famous for. Let's go back and explore Meraki's journey and what you know about that for IPv6. How have we chosen to go about supporting our customers with this?
So Meraki's journey was inexistent. Zero. Nada. I don't know what other language to say it when I started, which is why I came to Meraki. I specifically chose, if I wanted to go work for Cisco, what area can I contribute all the experience I've gained over the years by dabbling into V6, routing, and all these things. And Meraki seemed to be the right place. They didn't have it. It didn't work. I wouldn't have bought it because it didn't have V6. So I said, this is a good challenge. And
so you are the knight in shining armor that's come in here on your horse to try and help encourage and evangelize it within Meraki as well as beyond.
That is correct, and it's been and it was a similar journey from when I started in 2005. You got to get a lot of the naysayers. I mean, I'm sitting with one right now.
Slowly but surely, you're converting me. When you started talking about that extra performance and that sort of happy eyeballs thing, I mean, that's quite memorable. I'll probably never forget that. That's attention grabbing. My skepticism comes definitely from the fact that NAT has done a pretty good job and the processing power is pretty high now, so it doesn't take super long for that translation to happen. But I get the point about, ultimately, if as humanity we want to make things better and faster over time, we need to do that in a very thoughtful way. And this is just now we're dealing with an anachronism which is sitting alongside this shiny new technology, and we're just waiting for everybody to catch up.
Yes, sir. And the thing about Meraki is that the whole idea of simplicity, I think we're sitting on a great opportunity for Meraki to provide that simplicity for the enterprise, which is the last missing piece of the stool, like I mentioned earlier, because we have the mobile providers, your ISPs, the content providers. What's missing is the enterprise. And Meraki has already penetrated the enterprise pretty well. Let's just one day just turn on V6 and it should be effortless. It's that simple button that one day everybody just wakes up, oh, we're running V6.
Yep.
That's the idea. That was the goal. That's the vision I had when I said, hey, I want to go work for Meraki.
Right. So you said that that things didn't look so great when you first showed up. So what have we done since then? What is the journey we've been on, and where are we at now?
Oh, the journey's been very fun because you get to see something grow up from nothing. So when I first started, I got my first batch of equipment. As an SC, you get to play and get a whole bunch of equipment and put it together. And I'm like, oh, I can't even pass V6 traffic, not even layer 2. What's going on? It was severely broken. So I had to kind of shimmy up different pieces of technology to kind of try to get V6 to work. But no matter what I tried, 2015, it was a fail. come 2016, we started to ask questions, learn how can we solve problems with V6, and that's the first attempt where the whole backend, the encrypted tunnel that we do between our devices to the dashboard, for example,
to the cloud,
is all done via V6 within a V4 packet.
Okay.
So we essentially, all our data centers turned off V4 from the inside, which was like, they started to see the light. Our engineers were solving problems using V6 because of the way that we needed to scale.
Right. Actually, that's a very interesting point, and not something I've thought about, and I'm sure I don't know the full detail of it, but just thinking about it logically, one of the things about the dashboard, of course, is that our customers sit there with a laptop in front of them on the same site as the equipment that they're managing, potentially. And when they make a config change or they want to look at a list of clients on their network, all that data's got to be pulled from the Meraki dashboard, so the cloud service that we hold at the back end, that's where the databases live. And speed of that is essential to us because we want to provide a responsive user interface for people on the Meraki dashboard. And if I understood what you said earlier, then V6 could be playing a part in trying to improve that sort of experience. For
at least internally, all the processes are talking via V6 only. Mm-hmm. We're still getting it delivered via V4. But those milliseconds inside the data center really help for that user experience.
Right. It all adds up.
Yes,
because we do expect, I mean, no matter what device we're using, and a lot of us are getting very adjusted now to the world of cloud-hosted applications. In fact, almost all of them are. I mean, it's crazy the way the world has transitioned from really computing power running locally to using cloud-based services like this. And the dashboard is certainly an example of that, with therefore a need to provide as responsive an interface as we possibly can. So it's a good experience for people.
Yeah. Now, specifically for our products, the journey really started with our switching platform. They were the first to dive into allowing V6 traffic to get through, at least from a layer 2 perspective, not from a layer 3. Then we added a little bit on our access points on the MR platform in bridge mode only, and layer 3 roaming as well. But always the switching platform was ahead. Now, that was around 2016, 2017. Now, come 2019, the access points, the MR team has actually overtaken and moved light years ahead from the MS switching platform.
I'm picturing some healthy competition upstairs.
And that's actually good. That's very, very good competition, because now all the products are competing to see who is V6 ready, who's going to be the first one.
Mm-hmm. That's a nice way to set it up. So what you're saying then is it's a much healthier picture that's evolving. And I think before we pressed the record button on today's podcast, we said that there are definitely some developments happening that we're not ready yet to share with the world, but there's
very
stuff
exciting.
Happening. All right. And I can tell you, folks, that Jeffrey is smiling from ear to ear. He's so excited about this. I don't think I've ever met anybody so passionate about a protocol in my entire career. But it's so exciting to see. All right, Jeffrey, is there anything else that you want to tell us about maybe some of the myths that you want to dispel about IPv6? Perhaps, is it actually harder to work with this protocol than V4?
I actually find it easier to work with, and it kind of goes, again, hand in hand with our whole story of simplicity, because IPv6 is very, very automatic. I do not need a DHCP server, for example, to be able to hand out addresses. So that's one less moving part to set up a network that you need, which means I've simplified my network.
Okay.
Because of all the automation that V6 gives. Now, people get scared of this big, huge, giant address. Well, guess what? It doesn't have to be that big, huge, giant address. You can control it. Like I said, you could put words in it so that way it stands out. I used to design my space to be able to tell me something. For example, I could tell just by looking at an address if you're on the wired or wireless space, because it would tell you literally based on the way that we've designed it to put a keyword. For example, we put coffee. If it had coffee spelled out, it was a wireless network.
So you have something memorable in the address that enables you to essentially summarize. Would that be a good word to use? So like summarize a bunch of the actual bits.
Correct. Because the fact that we can use words and letters, now you can get a little bit more creative other than memorizing, I know that 10.5, that's my wireless network.
Okay.
So those are kind of cool things that actually simplify the way you work with IPv6 because you're designing your space and you're less bound by the limits of what we had with subnetting.
Right.
And the other thing, too, is you don't think about it in terms of an address anymore. So addresses become irrelevant. I don't need to know that you have this address or that address because, first of all, they're changing because of privacy. So privacy becomes an option that v4 didn't give us because NAT is not security through obscurity. That's not a thing.
Right.
So our addresses are constantly changing. So that gives us a factor of privacy. And again, it doesn't have to be a big, huge address that you have to be scared of. You don't have to memorize your addresses. However, your brain does adapt and you start memorizing addresses eventually.
I am sure that someone like yourself...
My brain got bigger.
I'm picturing Jeffrey like reeling off an entire IPv6 address in his sleep. So I'm trying to think, what was that? I had a question in my mind just now and it's gone right out. It was around the deployment of those addresses. So with v4, back in the day, you could actually go and buy chunks of the internet, essentially. Like you said earlier, you've got a /16, Class A, Class B, Class C network. How does that work? Like, do you actually buy chunks of v6 addresses in the same way if it's constantly changing like you're describing?
Yes, you do. You buy them exactly the same way. You still go to your internet registry and you buy a chunk. However, now they're being a lot more generous because, again, it's not about an address. Right now, it's really easy to get big, huge chunks of addresses.
Go on, tell us roughly. Just millions? Are we in the millions at this point?
Yeah. Right now, we've only allocated a /3 from the entire available space, which is not even 1% of it. And that's what's available to the world to start consuming, to start handing out. So
that's a lot of addresses.
I mean, just one, for example, /64, which is the least common denominator that we assign to a subnet, for example. That's about the size of the entire IPv4 internet that you're getting just for your home, for example.
Right. There's this famous, and I'm not massive on North American sports. I mean, listeners, I'm sure you can tell I'm not originally from these parts. But there's definitely a hockey phrase that always sticks in my mind. I think it was Wayne Gretzky who coined this phrase about skating where the puck is going. And so what that says to me, if I think about that phrase, is v6 is something which network engineers should be gaining familiarity with and thinking about adding to their arsenal of capabilities so that they can help spread this good hygiene. And we just do this organically. Does that sound about right?
That sounds about right. And all our Cisco certifications include IPv6 in some form or fashion. So at least 2 or 3 questions will show up. So at least don't miss those. Also, IPv6 is already and has been running on your network for about 8-9 years now because every OS defaults to it. So
yes, I remember that happened.
From a security perspective, if I just go in and start spewing out v6 addresses, I can probably take over your whole network without breaking a sweat because all your operating systems are defaulting to v6. So security there.
I mean, it's really like it's just happening organically because if all of the computers are natively running v6, if most of the internet is running v6, then it just makes sense to be filling in the blanks in between as you're describing it. You're slowly turning me. Okay, you're slowly turning me from a skeptic.
He's actually smiling, a real smile this time.
So, okay, there's got to be people listening, I'm sure, who like me, feel like they need to get more familiar with v6. They work with v4 every single day, and they want to start sort of building up their knowledge and maybe even playing with it. What would be your recommendations to them?
So the fact is, it's 2019. There's a lot of resources available. Depending on the part of the world you're in, your internet registry, they have initiatives to help you with v6. They have a lot of resources that were not available when v4 started. So take advantage of those. That way they're in your local, I'm going to call it currency for now.
What kind of resources are we talking about?
How to For example, what it is, just understanding how the IP addressing schemes work, recommendations on best practice on how to do IP addressing schemes,
Right.
how to divvy up your addresses. I mean, really, really practical stuff, because now we've been doing it, operationalizing it for about 15 years. So you get that knowledge that I did not have the luxury to have in 2005.
Mm-hmm.
In 2005, I was creating the best practices because there was none.
Right.
And we made a lot of mistakes, and we learned from it. And we learned from it in such a way that we had to readdress 2-3 times. But in V6, that's easy. And we also advised the IETF how to make certain things more practical, make adjustments to it. For example, providing I'm getting technical now, RA options to include DNS as part of the automated delivery of an address, for example. That's something that was not available 10 years ago that we've learned over the years.
You pretty much lost me on that one, but it sounded great.
It makes your Android work better. That's all you need to know.
There we go. I'll go with that. I'll stick with that. Jeffrey, this has been an amazing conversation. I think we've covered V6 very effectively. It's so exciting seeing your passion for it. And that's one of the things I love about working here at Meraki, is that I get to work with so many people like Jeffrey who are just really into this stuff. And little did I realize before we sat down and I started probing your background that we're you could argue that we're talking to one of the pioneers of V6 in the real world in terms of deployments, by the sounds of things. That's exciting.
Thank
I'm going to get your autograph now. All right. Thank you so much, Jeffrey. We're going to wrap things up now. I want to thank you so much for joining us on the podcast today. It's been great fun again recording this for you, and I hope you found it an interesting and engaging use of your time. And let's just find out from Jeffrey, like, any last words, any sort of tips or advice you'd give people.
IPv6 coming to a Meraki network near you.
Wow. Okay, we didn't rehearse this. You can tell, folks. Okay. Thanks again, Jeffrey. All right, so I want to thank you again, like I said, for joining us. We want to make sure that we're getting some great topics covered that you find useful and interesting. And so how can you feed that back to us? There's a couple of ways. First of all, we have the Meraki community. If you just search for, or just go to the address, community.meraki.com. I don't know if it's a V6 address, but maybe.
Actually, Simon, it is. Meraki.cisco.com is V6 enabled. Meraki.io is V6 enabled. So go check it out.
Okay. So the community is definitely a place where, and now you know that, you've got to do it. It's the place where you can go and tell us what you're enjoying about the podcast, what you'd like to hear us talking about. I'm super keen to make sure we're making this as relevant for you as possible. Or you can just ping me direct. I'm on Twitter, easy to find, at Meraki Simon. And I definitely encourage you to do that. All right, so we'll be back with another episode very soon. Thanks again for joining us, and bye for now.